All right, good morning, everyone. Good afternoon for those of you guys on the West Coast or on the East Coast. All right, so thank you all for joining us for today's webinar. We're going to be talking about SOLIDWORKS Plastics injection, or SOLIDWORKS Plastics. So the primary focus for today's conversation will be looking at avoiding common problems in the injection molding process. So let's get started. Now, I wanted to start off today by just giving you a small but funny quote. Okay, I have one word for you: plastics. There's great future in plastics. It's quite funny. So I want to talk a little bit about what plastics is. So if we look at older commercial products, older products that have been available to us, we can look at what was available back then. What did they use in order to achieve the same aesthetics, or to achieve the same results as we get today? And as we look, we can see there's lots of leather, there's lots of steel, there's lots of metal. Things that are very expensive, things that aren't easy to deal with, aren't easy to manufacture, aren't easy to reproduce. Versus if we look at something more common, a little bit more modern for today's environment, we can see that almost everything that we use in these days is plastics. If you look at your laptop, there's tons of plastic on it. Your cell phones have plastic on them. Your cars are filled with plastic. They might be coated in leather, right? But underneath that leather is still some plastic that's actually providing the backbone for it. So we can just see that over the years, the growth in plastics is phenomenal, just exponential growth. We're starting to use it for anything and everything. So let's dive into today's conversation. So today's conversation, we actually want to talk about the plastics injection molding process. Now, this is something that is widely adopted, right? Almost every product that we can think of has some form of plastics inside of it. And so if we were to look at how all this plastics is done, over 80% of the world's plastics is actually done through the injection molding process. So there's a lot of potential product usage out there for how this stuff is accomplished. Now, how we're doing this for today's presentation, I want to break it down into three sections. I want to break it down into the engineering behind it. I want to break it down into the setup process of analyzing this injection molding process. And then we'll actually go through the analysis, understanding how this stuff is done and what drives it, how we understand these end results. So let's jump into the engineering process. So what we're going to do is we're going to define the process a little bit. We're going to talk about what molding is, and then we'll actually dive into SOLIDWORKS and take a peek at these setup processes and these results reviews. Understand how we can tackle injection molding to make sure that we're getting the best, cheapest, fastest plastic parts out there that we can. So getting started, like I said, for a long time, plastics has been considered this black magic, right? This tribal knowledge, this science, everything basically this innate knowledge. It's not very easy to understand all this stuff. So there was lots of misinformation about what's happening here. So the biggest question that we always had is, okay, is it easy to adopt? Is it easy to pick up? And the answer is yes. It's actually relatively simple science, right? And in a lot of cases, we'll go to seminars or presentations where they're talking about the injection molding process, and they're talking about the science of injection molding now, this adoption of the science behind it. So we can see that it's starting to move towards this more common process. And so for injection molding process, I like to break it down into what I call the simple science. So if we're looking at this injection molding process, it's not something that's terribly convoluted, right? Essentially what we're doing with this injection molding is we're taking this empty space, this volume of air that's encapsulated by some body, and we're shoving this molten liquid into it. And then once this cavity gets filled up, we let that molten thing cool down. And that's where we get our plastic, right? We're getting this plastic component that's inside of it. Once it's cooled down sufficiently, we go ahead and open up that space and we retrieve some component that's now in that same shape as that empty volume of that empty space inside of it. And what we get is that plastic part out of it. So what does this mean for us? So inside of SOLIDWORKS, we can do this exact same process, right? Where we can push a molten material into an empty volume and understand this whole process and do it virtually. Start to understand exactly what's happening inside of this entire process. And how we're going to do that is we're actually going to use SOLIDWORKS simulation or SOLIDWORKS Plastics in this situation. And so what does that entail? So the SOLIDWORKS science, pretty simple. What we'll do is we'll end up defining the shape, we'll define the material, We'll define an injection site location. Essentially, we'll tell it where we're going to start to push this material in from. We'll run the analysis, and then we'll actually go through and review some results so we can see what this black magic, how everything's turning out, so we can fully understand everything that's happening within that mold for us. So let's go ahead and jump into the setup process for this. So what does this entail? Now, like I said, it is a fairly simple process. So again, what we're going to do is we're going to jump in and we're going to take a look at the shape that we're trying to fill. We're going to define the material for that volume. We'll define an injection site location, and then we'll go through the process of actually running an analysis and reviewing these results. Now, my goal for today is we're actually going to take a look at this model here for us. So, relatively small model, but there's a lot of features. There's a lot of potential problems that we can encounter trying to perform an injection on this body here. So what we'll actually do is we'll go into SOLIDWORKS, we'll look at this body, and we'll walk through the entire setup process so you can see exactly how SOLIDWORKS simulation can tackle these individual problems that we're looking at. So I'll go ahead and kick over to SOLIDWORKS here for us, and we can see that the part is already ready to go. Now, this is an interesting part because there's a lot of features, there's a lot of functions, a lot of things that are going on in here. You can see as we rotate this thing around, it is a body. There's hard to reach surfaces, places we might try to inject or start to push plastics in. But so for today, what we're going to do is we're going to tackle a couple of different situations where we're going to do the injections, what materials we're going to use, and overall just try and get some results out that we can analyze and figure out what the best potential solution for injecting this component is going to look like. So what I'm going to do is I'm actually going to start walking through the injection molding process inside of SOLIDWORKS simulation here for us. So with SOLIDWORKS turned on, you can actually enable SOLIDWORKS Plastics. Using SOLIDWORKS Plastics simulation, you'll get a nice little toolbar at the top, which allows me then to access all the simulation stuff inside of here. So I'm actually going to walk through this process. What I do is I first have to define this body, let the SOLIDWORKS software know that I want to inject a molten plastic, that fluid volume, into this space, what's taken up by this model here for us. So what I'm going to do is I'm actually going to create a mesh. So the mesh is actually capturing this entire body, letting the software know exactly what it's trying to accomplish. So we'll go ahead and start with just a simple mesh here for us. We'll do a shell mesh. What the software does is it actually goes through and it breaks down this model into very small sections so that it can, essentially what it's going to do is it's going to look at each of these small triangles and try and fill up each triangle individually, one by one, from our injection site until it encapsulates the entire body. So it's a process known as finite element analysis, essentially looking at a very large problem and breaking it down into small chunks to complete very quickly. So we have our model. We've defined the shape now with all these triangles essentially going through and telling us where everything's sitting. And we'll start walking through the injection molding process. So you can see we have a tree on the left-hand side. And like any of our simulation products, it's a pretty simple process. All we do is start at the top of the tree and select the relevant options as we work our way towards the bottom until we get to this final option for run. So we'll go ahead and start at the top of the tree here for us. We've already done our shell mesh. If we have channels or if we have runners, sprues, anything that's in our model that we need to capture, we'll do that for the channel design. We'll actually go through and capture those so we understand where cooling lines might be, where runners are, so forth, so on. We can add a virtual mold, so we can actually say the volume of the mold on the outside and what the materials of that mold are. We'll look at the material that we're going to inject into our model here. So if we go and right-click, just open up that database. We can select any of the available materials here for us. So with SOLIDWORKS simulation, there are over 5,000 materials that are predefined in the library for us. And if the material that we're looking for is not defined, we can actually create a custom material as well, just based off the material stats. We'll go ahead and select the material here. We'll just go with an ABS at this point. And we can select, let's do this one here. We'll hit our OK button. You'll see that you get a green check mark on the material, just telling me that that's been fully defined. We'll chug along in this process so we can define the mold material if need be. Or we'll jump all the way down here to the injection site location, where we'll tell the software where we're going to start shoving this, this molten plastic in from. Now, there's a lot of potential surfaces that we can use for this model. So for simplicity's sake, I'm going to go ahead and just select a location here for the setup process. So we'll go ahead and just select like this edge here. We can define the diameter of the gate in inches or in metric. And we'll add that location so that the software knows now it's going to start shoving the molten plastic in through this location. We get a nice little graphic telling us how this is actually coming through for us. Go ahead and select our OK button. And essentially, for the simple analysis, this is done now. We've gone through, we've defined the space, we've defined the material, and we've defined where we're going to start shoving that molten plastic through so that it starts to fill up our fluid body here for us, our empty volume. From here, we can just jump down and actually run an analysis. And what will happen is SOLIDWORKS will actually jump through and start to calculate all the filling process. And what we'll see here on the right-hand side is as the solver goes through and starts to fill up the body, we'll actually get a real-time preview where we can see the plastic starting to fill up. We can see how the plastic is actually running through this body and what's happening with it. We can review these results real time as it's going step by step if need be. So we can actually start to look at something like maybe shear stress. We can look at like the frozen layer fraction, so we can see if there's any excess cooling happening very rapidly there to solidify the plastic mid-process. Or as it starts to complete the process, once it gets to 100%, these results will be a little bit more relevant to our actual analysis portion. So pretty simple on the setup side, right, where we just simply go through the tree, select each of the individual items, and work our way through until we've essentially completed it. Now, we'll go ahead and let that solver run. It's at about 90% now, so it's almost done on that run side. But once we've finished this, once we've completed the setup, we've started to run, we can actually jump into our analysis portion, where we start to review these results, where we're looking at plots that have various colors to let us know what information is actually occurring. And we can start to dig in for actual numerical values to understand fully what's happening here. Now, with our simulation complete, I can actually show you what's happening in here. So we've run a quick analysis. We have that ABS, and we do have what's called a results advisor just popping up on the right-hand side of the screen here for me. This thing's going to give me more information as I start to dig into each of the individual locations inside the simulation. So currently looking at something like our fill time, we can actually see what does fill time mean. Using this a results advisor, it'll actually give us a definition of the fill time and start to explain to us everything that's happening with this, what can affect the fill times or how can it be manipulated. We're getting a yellow light up here, just letting me know, hey, the fill time, while it looks good, right, we're using less than a single second to fill up this entire volume, it did take quite a bit of pressure in order to fill this volume up, so about 8,400 psi. We'll start to dig through some of these other results. We can look at the pressure at the completion of the fill, just like we saw there, 8,410 psi. We can see the location of all those pressures. So where's the pressure high, where's the pressure low? We can look at something like the cooling time to understand how long it's going to take each of the individual locations in this model to cool off enough to actually start the ejection process. Again, just looking at that information there on the left-hand side. Or more relevantly, we can look at something like weld lines. We can start to see where the plastic flow fronts are all coming together and if they're coming together in critical areas, areas that might be sensitive to stress values. And so as we check that box for the weld lines, we can actually see that the results are showing us where those flow fronts came together and what angle they came together at. So we start to see like weld lines in between these thin bodies over here. Something that might be of a little concern to us if we know that there's going to be any forces applied to this model once it's actually in use. Might lead to like cracking or breaking. We can look at things like air traps, seeing we've shoved all this molten metal or this molten plastic in there. And it fills it very, very rapidly, trapping air into certain regions. Where is that trapping occurring at? Or we can look at things like ease of fill. Is there any difficulty filling this model? There's a lot of potential results we can get out of this just to fully understand this process. So what I'll do is I'll go ahead and kick over to a result or to a study that we've completed just a little bit earlier that has the full results done up. And we can start to look at like the full flow and pack results. So this is using a little bit different material. We can see the pressure needed in order to complete the packing process. If we look at the flow, we can see the same fill time, relatively quick, less than a second. And we can start to dig through everything here. So again, weld lines we're injecting from that bottom site location. So we're getting a number of weld lines across the interior faces here for us. Look at the cooling time. It takes about 2.5 seconds in order to cool sufficiently. You can see what regions are taking the longest. Look at the frozen layer fraction, how much of that is cooling off before the fill process is finished. Or we can even look at things like the shear stress. So as we're injecting from that bottom location, we can actually see what kind of shear is being induced on the plastic due to just the running, basically how the model's filling up. If we dig into the packing process, we can look at the pressure at the end of the packing, shear stress post-packing. And the cool thing is all of these results are fully 3D. So we're able to manipulate the model and look at it from every angle and to get a full, better understanding of what's happening. So looking at this model, right, we had a lot of pressure during our fill time here for us. So we're up to, what was this one? 140,000 PSI, I believe. 14,000 PSI, I'm sorry. 14,000 PSI in order to complete the injection on this one. Pretty high pressure gradient in order to fill this volume up. So what I wanted to do is looking at this this model, we could do a couple different things, right? We could change the material in order to try and bring that pressure gradient down. We can move the injection location. There's a number of different things that we can do. So what I've gone ahead and done is created a second study. And what I've done in the second study is I've gone ahead and removed that hole that we had right in the center. What I'm going to decide to do is actually do a post-process. So I'll fill this model up, and I can use this volume, this location here, and I can use a post-process to actually drill out that hole so it gets nice and clean hole, but it gives me a little bit more surface area to work with, trying to eliminate some of those weld lines so we don't get as much cracking. But then we might introduce other issues, right? We might introduce cracking due to the drilling process at the end of it. So if we were to look at this simulation, basically the same thing, right? We have our mesh set up, we have our material selected, but then for the injection site, I've actually gone ahead and selected the middle location there for us. We're going to inject right in the middle of that big volume. And we can kind of take a peek at how that changes the results. So if we were to look at something like the flow time, we still get a relatively equivalent flow time, right? It's taken less than a second, but just a fraction longer than injecting from the bottom location. But if we were to look at something like the pressure at the end of the fill, previously we were at about 14,000 on the other one, and this one we're about 10,000 PSI. So we were able to bring the pressure down by about 4,000 PSI just by changing the location of the gate. We can look at some of the other results like our weld lines and see where the weld lines are occurring now. So instead of getting weld lines on the center down here or in the middle regions, we can see that the weld lines have now moved out to hopefully what we would consider less stressed regions, regions where we're not going to encounter as many issues. We can look at something like the cooling time, about the equivalent on the cooling time, right? 2.4 seconds. Ease of fill. So we're seeing there's one region that might be minorly difficult to fill up. And we can start to dig through things like sink marks. So if we're anticipating any sink marks in this model, software will also go through and dig that up for us, try and find those. And well, lastly, but we can look at something like the air traps. So how are we moving the air volumes? So not much movement on the air volume, so what we're able to do is move the pressure, right? We were able to adjust the pressure, so it's not using quite as much as it previously was. We can look at our pack results again. Looking at the pressure at the end of the packing process, we're able to bring that down pretty significantly, down to 4,000 PSI. Look at that shear at the end of the model. So we get quite a bit less shear, right? We're not seeing as much coloration in the plot, and if we were to look at the actual numerical values, frozen layer fraction, everything's completely solidified in this model, of course. And we can even look at things like volumetric shrinkage. So in this case, we're not going to really see shrinkage just because the part's so small. We're applying enough pressure, enough everything behind it to prevent it from doing that. But what this does is it gives us a lot of value, a lot of power to see what's actually happening. So if we were to go through this whole process, we can actually look and see, okay, what is the difference between what we've done currently what we've done with this study, where we're injecting from this bottom location. And if I go ahead and animate it, we can watch that fill process, what it looks like. Go ahead and slow it down and replay that here so it comes through on the webinar for you. You can see, even in those weld line regions, how the flow fronts are coming together, how it's calculating those weld lines. And we can look at the other result, where we'll go back to the first simulation where we did the injection from this bottom location down here. And we'll animate it as well so we can see what's going on, what's happening there. So just changing up the location of the injection site, and we can see what it's doing to the flow fronts, how it's changing this flow around a little bit for us. Go ahead and turn on those weld lines so we can actually see them during the animation. And we can see as that flow front starts to come through and fill up the body on exactly what it's doing. So again, we're not running this real time. We're running at a very slow motion so that we can actually see as the flow front's moving forward and all the plastic is kind of meeting up and filling up this volume for us. I'm going to rotate it onto the other side so we can see that result as well. What it's doing is it's allowing us to get a full, better understanding of exactly how this body is filling up, so we can anticipate issues where flow front might not work, where pressures might be too great for the machine that we're trying to inject it on, and so forth, so on. So with that, why do we use something like SOLIDWORKS simulation or SOLIDWORKS Plastics simulation? And the reason is the cost of using something like this versus trying to do it real time or trying to do it based off the results that we're seeing in the real world is the value of it or the cost of it is quite significant. To make small changes post-process when we're actually going through the process of doing the injection is very impactful, right? It gets more and more costly the longer we wait in order to make these changes. Versus if we're able to do something on the analysis side, the virtual side, and anticipate these problems, we can head them off, essentially eliminate that cost associated with the physical production or the physical change of this. So with that, just want to recap again what the SOLIDWORKS Plastics is. So SOLIDWORKS Plastics is a simulation tool. It's what we consider a CAE or a computer-aided engineering tool. And it's used to help us identify issues with the injection molding process. And again, the reason that we look at something like this is because injection molding is used in over 80% of all the plastic products in the world, right? So as all of these different components, all these different things that we're looking at, there's a lot of potential ways to build them, but a majority of them are actually built through this injection molding process that we know can get quite costly. If we're to look at the value of, or the cost of like a new mold, it's not uncommon for these things to get into the $10,000, $100,000, even $1 million range in order to build a mold. So what we'd like to do is we'd like to tackle this a little bit earlier in the process and make sure that we fully understand exactly how our model is being filled or what this process looks like. So with that, that's the end of today's presentation. If you guys have any questions, I would love to hear from you, and I'll stick around and answer some questions for you. Otherwise, I do want to thank you guys for giving me your time today to join us for today's session on SOLIDWORKS Plastics Simulation. For those of you guys that do have questions, you can use that GoToWebinar interface on the right-hand side of your screen. There should be a questions dialog. Please feel free to type in there, and it should pop up those questions for us here. All right, so the first question came through, was this webinar recorded today? Yes, it was. So I did start the recording a little bit early, so there's about 10 minutes of just white screen at the beginning. Going to clip that out, and then it should be up and ready to go. I think by this afternoon it should be available for all of you. All right, another question just came through on the materials, the default materials. So SOLIDWORKS, like I said, does come with a number of predefined materials for us already. So if we were just to open up the initial engineering database, we can dig through the materials based off the type of material. We're actually looking at like a polycarb or an ABS, so forth, so on. They're broken down, or we can actually sort by company as well. So if you work with a specific vendor or a specific supplier, you can look to see if their material is available, something like DuPont Engineering Polymers. We can look in there and see all the materials that are readily available from DuPont. Another question came through, is there a trial version available? That's a good question. Typically there is a trial version available, but I would refer to the sales reps. So your sales rep will be able to work with you on trying to get a trial version if you're interested. All right, I will do. Let me grab your email address real quick, and I can shoot you a direct email after today's presentation. No problem. Thank you for attending today. That is a great question. Somebody just asked me, where can I find the recorded webinars? I actually don't know the answer to that. Let's see if we can find them real quick. So we did launch a new website over the holiday here, and I am not familiar with where we are putting them currently. I think it'll be right here under News and Events, Decide Webinar Archive. Yeah, it looks like it should be uploaded to here. News and Events, Decide Webinar Archive. All right, another question just came in. Is this a trial and error to determine the proper injection point? So you can, of course, use this as a trial and error process to identify an injection site that's going to work for you. But there is more value to it than just that, right? So we can move the injection site to a different location. But what it allows us to do is it allows us to change like thicknesses of the model to see how it's going to adjust the flow. If we want to change like a wall thickness. I've seen interesting situations where customers add like small little bubbles on the far side of the injection site in order to reduce the amount of shear that's introduced when they're performing the injection site. So it is a trial and error. It allows us to go through and fully understand what we can adjust or what we can manipulate. But it's to give us a full understanding of exactly what's happening in that injection process so that when we get to the machine and we're about to inject it, we know exactly what's going to happen, or we have a fairly good degree of confidence of what the result's going to look like. So if we're going to receive things like short shots, right? If we have wall thicknesses so small that we're not able to inject it quick enough, this will help us to determine if a short shot's going to occur. The software will actually stop mid-solve for us and say, hey, I was not able to fill the volume for you. This is what it's going to look like. There was a question, does this handle the extrusion process? No, unfortunately, this software does not actually handle the extrusion process. This is only the injection molding process. So filling a cavity with molten plastic. All right. I don't see too many more questions coming through. Oh, another one. Can I set up a new material manually? Yes, the answer is yes. You can create custom materials inside that library there. Just opening up that database here for us. You'll see there's an option for user-defined materials. can actually create our own subcategories and our own materials. So if we want to create, let's do a decide material. And then from that design material, we'll go ahead and add a product inside of it. And I can actually go through and start to fill out all the information relevant to that material. So we'll call it a name. Define the melt temperature of it, the minimum and maximums, what the mold temperature is for this material, and then start to define everything else about it. So where that glass transition temperature is at, what the viscosity looks like, if there's any fiber inside the material, so forth, so on. Just kind of digging through all of these various fields to fully capture what the material looks like. No problem. All right. Okay, so I don't see too many more questions coming through. If I miss any questions, I apologize. Please feel free to shoot me an email. You guys should have gotten an email from me to remind you about today's webinar. Please feel free to respond to that or email me directly, and I will get you guys the answers you're looking for. Thank you all for attending today's webinar. We hope to see you guys next time.